So getting back on part two of checking out this ECU, I've mapped out a lot of the test points on here all across the board. Let me see if I can get a mouse view on this one. You can actually see where I'm going to be at. There we go. Cursor here. So I'm going to start with the different test points. And on the test points, you'll see like a little crosshair right in this area here. And you'll start to see all the test points pop up. I'll show you what it's actually doing compared to this. I found a couple of bad spots. I compared it to a good ECU. So let's get to digging into this thing. I can kind of show you what's going on, and we'll go from there. So we'll go ahead and get set up here for it. Tester. I'm gonna have to unplug it and plug it back in. So give me 1 second. See, we got unplugged. We'll see if this thing actually reconnects when I plug it back in. Give me a status if it's detected or not. But I wanted to get it over here and show you the testing that I've done on this thing. We'll plug it in. See if it'll start reading again. Give me a second. And okay, it came back up. So all right. Now did the screen work it up? All right, we're gonna test things out here for a second. Give me 1 second. I'm gonna make sure that all this is working properly. Oh, I knocked something out. Don't know what, but I no longer have the app showing up now. Let's get this back over here. It crashed on me. I saw that. I'll just reopen it real quick. There we go. So let's open up database, load an image. So make sure that it's actually seeing the. Yeah, okay, it is. All right. It changed my view. I did have this down here at the bottom as my let's see if I can change that back. All right, so is there so a little bit. Show you all the test spots, and then let's get to testing. I'll show you what I'm testing out here. Use this camera spot. Let's go and get it in test mode and get my data set up. Load data. So my data is backside circuit. I'm going to go to test point 1. So I'll show you exactly what test point. Right up here in the top corner. You see it right here. Let me a little bit smaller for you. There we go. So I'll show you the test point up there. These are the points that I'm going to be testing out. Got to get my ground on here. So I can find my ground there. These other ECUs out of the way. 9 ECUs to work on. We're busy. So let's get the thing a little bit organized here. And I'm going to get my wire leads. Start grounding this. Sure, it'll be correct. It's here. So let's get the pin out for the ECU. So 1, 2, 3, 4, 5. That's my ground pin. I'll verify that with my multimeter here. Make sure that is my ground pins. 1, 2, 3, 4, 5. Yep, that's my ground pins. Hook that up to the tester, and we'll pick up another ground. It's going to be on pin 18, 17. I'll do 17. It's on the same one here. It's going to give me a ground reference there. Okay, so now we're going to get to the test. Now I'm going to show you what the auto test. So let's set it up on an auto test. And I'm going to go to test point 1, and I'll show you this little crosshair right in this area. That's my test point 1. I'm going to check it out. Bring the camera over here so you can kind of see on that. Hear the sound. Now I go to test point 2. Looks good. Test point 3. It's good. Test point 4. Test point 5. Test point 6. And I skipped 7 because they're both together right there on the same connection. So here's 7. There's 8. Here's 9. The next one. See as it goes across the board. This is just a compare test against my good ECU that works. Alright, so now let's see where it's showing me to go at here now. Okay, so on this section, I'm right here on this first pin. So let's test this one out here. Good. Good. This one should be my bad one. Yeah, see how much off it is there? Looks like there's a little resistance build up compared to the original. Original is the red line, so the yellow one is my test line. I'll test it one more time. And you can see what the difference is in between the good one and the bad one. So that pin, I think I traced that pretty much over. I got it in my documentation. I'll have to see what that goes to again, but I got it in my documentation. But let me go ahead and go to my next one. I got to select it. It doesn't let you auto select your next test plan. So I'll go to pin 19 now, which is this pin. Is good. 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 Now you can test this one. Test this one. Okay, so I see a little difference right there in this one. I marked it as well when I was testing it beforehand. Got a lot of glare from my, let me turn this down just a little bit, see if I can get rid of some of that glare. Maybe even turn it off. Let's see. Yeah, let's turn it off. Looks like it's okay. I got most of my glare from my overhead light here. But let's go ahead and go to the next step here. 1.5. Test her out. Good. 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 Grounded. Yeah, good. This one's gonna be, yeah, that was correct. It just didn't read it time. There we go. See, pastance there, but it says it's different. Let me check it one more time. Okay. Do it one more time. Yeah. As you can see, when it lines up like that on a capacitive, it's actually reading okay. Let me just go to the next one here and select it. These testers are not absolutely perfect, so here's the first pin. Okay. This one I tested before and it was bad. As you can see the red line, it is actually straight across with no resistance on the original. But on this one I have resistance, like there's a resistance built up into the circuit. And if I remember right, this one was for the O2 sensor. He was having problems with ridge conditions and stuff, and this resistance right here would actually cause the O2 sensor not to read right when voltage comes into it. So having that extra resistance on the voltage scale, that's just going to um, throw off the reading of the O2 sensor's input voltage. So, because they have more resistance on it. I don't know how much different it would be, but he said that he was getting some conditions where it was really rich and dumping a lot of fuel, and that could definitely be one of the causes right there, is because the circuit um, has that extra resistance into it. So let's just keep going here. We go ahead and select the next one. Matches the ground. Let's see, there's a transistor. It's good. You got a transistor. Maybe a transistor. It's got some weird curvature to it. Capacitors, they always act a little weird with this tool, but you can see it matches up after it charged up. And so we'll go to the next test here. It looks good, so let's go to the next one. Let's see, which one am I at here? I lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, this should be this one. Okay, and then this one. Good. Ground. Yep, that looked a little different, but now it's matched up. It just took it a second. I'm only inputting 5 volts at 10 hertz, so it's really low voltage. It's not really going to hurt any of these circuits or anything like that. Okay, looks good, and it showed that the test is complete. Well, it shows on my screen. It's not really showing it on your screen, so let me clear that out. And I could do a report test. And the riser board failure. Sorry, you can't really see this part of the video here, but I will share it with you real quick once I get it done. Save it, and I will open this up, and I'll share this part of the screen here, kind of show you what I'm seeing when I look at these test reports. That way you kind of get an understanding of what's going on. Sorry, give me 1 second. Give a window capture. Let's select riser board. Son's in there having fun. Sorry, I'm like, has a camera going there, but as you can see, after the test report, they bring this up. I can actually sign it, doesn't really matter. Test point single database with 51 of them. That test out these 3 little riser boards. I can actually show you what the riser boards look like real quick. So kind of give me an idea. Let me move this up real quick. I'll move that right there. Just unplug it. Bring this over. Real nice and easy. And these little boards that rise up here off the connector, they're non-repairable because inside of them they have a ceramic board, and a lot of the traces are silver and looks like they're laser etched too. I pulled this one off back here. I pulled this case cover off of it, and you can see as I put some little bolts back through it just to hold the case back down on top of it again, nice and secure, where the board don't move. There is a IC that's in a jelly material, heat dissipating jelly, and it's conformal coating. And inside that is laser welded micro wires. So like if you touch that and damage that, it's over. It ain't gonna work again. There's nothing you can do. And I got the same thing in these other units here. Those little red covers that you see right there. I don't know if you can kind of see it on the camera or whatnot. Barely see it in the camera, but those little covers are the ICs that have like a gel fill inside of them. It's the same material that you kind of see right here on the edge. Already it's kind of coming off. Yeah, that whole inside is just full of that. But anyway, yeah, if you mess those up, it's done for. You're not fixing anything else on this board. You'll end up having to just find another one and take all your components off this one. I have tested all the transistors individually. I tested all the capacitors individually. And I got databases for all of them. We ended up replacing a lot of the caps. That's on here. A lot of these other ones that are the glass ones. You can't really see this other board too good, but you know, these other little glass ones here, that transistor was replaced. Because they're not the same as these other ones here. The ICs, they tested out decent. I didn't have any problems with those. Those are ones I actually have a part number on. These, I don't have any kind of data sheets on either of these. And it's labeled VV360, but that is not the part number. It's something that was just put on these chips. I kind of mapped it out voltage wise on there and what goes to what. Which I kind of made my own little blueprint and everything. I powered up the ECU, tested all the pins, seeing what the voltages were, what the inputs and outputs were, and what the voltages were on these transistors here, and everything else. I mean, it don't look good. All these like big resistors here, these like little 15 ohm, 270 ohms, a little 15 ohmer there. This guy right here, that was I think another 15. Is glued down, but everything looked good. All my caps look good here. This little ceramic resistor right there is good. On these 47K big, I got one here, 47K, and then I got another big 47K. These actually detect from the ignition system over and goes on to I forgot which one exactly was pin number one that it talks to. I would have to look. I think this one was like pin 4, and this one over here was like pin 1. That talks to the ECU. And I'm gonna be mistaken on pin 4. I have to look back through my documentation and stuff again, but I remember one of them goes to pin 1, senses from the ignition system, and it sends an output for driving the injectors. So the ignition module handles the coil pack and all that, and the fueling is handled on the computer through these ICs. Mostly these two and this here. This is kind of like a preamp kind of deal that switches on this. It turns these bigger transistors. I kind of mapped everything out. I might share that online. I don't know yet. It took me a lot of time to kind of map where everything goes and testing out all the transistors, making sure everything was good on it. But the problems that I had, that he had with the vehicle, was rich conditions and some weird issues with heart throttle fueling, which could be related to that O2 sensor. Just some miscellaneous errors. Everything on here checked out, even the transistors on the outside. It's just something to do with at least two of these boards, and I marked them, the spots that I compared to an actual good ECU. So this board, they both have issues. I think this one had, I think it was a cylinder head temperature sensor. That's what that one was actually supposed to test out. And this one over here is for oxygen sensor. So that's kind of the issues I have. If it's not measuring the cylinder head temperature correctly, it can't determine temperature wise that it needs to add extra fuel. It might think that the cylinder head's a little cooler than what it actually is. So fueling, it might be underfueled, or it could be overfueled, depending on how the circuit actually checks out with the sensor. Since I don't have the vehicle, I can't really test that. But the oxygen sensor, that definitely had resistance on it, so it's actually bringing some of the voltage down on the positive side of the voltage. So that's actually going to drop, add a little bit of current to the O2 sensor and bringing its voltage down. It'd be kind of like the voltage divider kind of deal on a resistor. But definitely something going on there. I just sent off the good working ECU to them, and we're going to try to find out if we can find another ECU that we can snag parts off of to get another one working for them. Because once these things starts, getting harder and harder to find, um, especially these three boards. Everything else here, besides the ICs, these two ICs, you can pretty much get everything else. Even the big transistors, if you can find the correct values, even though you don't have a data sheet for them. The ON642 and an ON732 is what's on these ECUs. It is California emissions. Anything else I wanted to talk about on this thing or um, tell you about? Just let me know if you have any questions on testing the ECU. I did have to get this transistor replaced out. It was actually bad. This is the only one that I could find that um, had close resemblance to the good working ECU. So ended up buying a minimum of like 10 of these. When you got to buy like a whole roll of stuff just to replace one component, and you got a bunch of them sitting on the shelves for years. It just don't make no sense. But the manufacturers they do that with the parts a lot. I wish they didn't for small guys like me. I don't want 10,000 parts on my shelf, just sitting there not being used. Thought about putting a bunch of my excessive amounts of resistors and uh, some of my capacitors and things like that. I was going to put those on eBay, see if anybody needed them. Some of my ICs that I have, transistors I usually keep because I can find something that's a similar value to an original and work with it, depending on what the voltages are, breakdown voltages, whatnot, or turn on voltages. But just want to kind of finish up my part two video and show you some of the stuff that I found that was now confirmed what the customer had issues with because he sent me back this ECU. I thought I had everything working, so he sent me his good ECU that I can make a database on that you kind of see um, that I can make test sheets for with UCore, the curve tracer. But let me get over here. I'll show you the PDF now, and you can see like what the test results are, and go from there. So on the data sheets, or not really a data sheet, but on my test sheet here, you can actually see the computer layout, all the little, well, I don't know if you can kind of see it on your screen, but there's green dots all the way across, and any of them that fail to have a red dot, which is very hard to see on your screens. Let's keep going down here. I'll show you each little test point and reports and stuff, and they'll tell you if it passed or failed, what the tolerance it is, and impedance difference. Let's get down to that is an error. Failed. So test point 16 failed, but that's because I probably didn't have a good connection on it yet, or it was charging up to the voltage that I pre-tested at. So it took it a second to settle down. As you can see on this next test point, the same point 16, test point 16, and looked perfectly fine. Let's keep going. So here's the test point 18 that failed. Showed impedance difference of 55%. You can see on the yellow line, sorry, that was my test, and this is the actual working ECU on the grid. So I did make a note on that. The test point 18 was the cylinder head temperature sensor pin 13. So that's what goes to the cylinder head temperature sensor. It is a heated resistor, basically on that. I forgot how many ohms it is, but it adjusts the temperature. So with this being off and it has more resistance on it, it's gonna mess with the coolant tank sensor. So you'll get incorrect readings by the ECU, so it doesn't know how much fuel to add. Um, to keep the cylinders cool and whatnot, because there is a cooling effect with fuel. And let's just keep going here. Show you the next failed test point. It was this one here, okay. 124. I checked it a couple times. And put a note that says yellow ECU one, which is not working. One had 2.1 microfarad, and the red eBay one has 2.3 microfarad, which that might be why this is a little bit different here. It didn't really grow a cause for concern, but it did fail against the original one. But this one acts more like a transistor turned on a little bit later. And this is a 5 volt still, so that was at 1 volt, and then the other one was turning on about a half a volt. So they kind of meet up, when they get to up to so yeah. So let's keep going here. Plus 25. What other things I have next to test about 24? It's on the opposite side of it. So, the next one, the capacitor that hooks onto it is actually on this pin and comes back around and connects to this pin. Comes up and comes down. There's only a capacitor, nothing else on there. It's a 2.2 microfarad capacitor. That's why there's a little bit of a difference right there. That's what I was thinking what was going on. That made the whole difference is that capacitor. Because you will get variances in capacitors up to about 10%. On this, my test tolerance is set at 10%. This was a little bit over, which is at 16. As far as that, it can be iffy, but I'm confident I can let that go. I don't think that would cause a significant amount of issues with the circuit. It's just a turn on, and it's got a little capacitance still. It's a transistor basically. It could be like a Xener or a diode, something like that. Maybe a mega base. Yeah. So let's keep going here and see where a failed one was. There it is. Test point 35. I made a note here. O2 sensor pin 24 failed on eBay ECU red line. Okay, so yeah, I just make a note. It was the red one. No other connections. Directly connects to pin number 24 of the ECU. So actually on the connector itself, it's actually around the connector itself, that's where it's got the connection to. So let's get up here. So that's a big difference right there. That is 90% difference. So as you can see, it comes up flat lines. And there's like no resistance right in this area on the working unit. But on the messed up unit, there is a straight resistance cut. It's almost like somebody put a resistor in there. I tested this trace, followed it, and it goes directly to 34. Yeah. So there's no other connection that goes to that. So something has failed inside that and make the O2 sensors read incorrect. I did it a couple times reading it, and then I moved on to the next. So everything else on like it is fine. And it just has a couple of tests there. A lot of them are about 3%, 6%, which is normal. Less than my page, 17 to 17. So it pretty much makes the whole report after I test everything out. So I can kind of show the customer, what I tested out. they might not understand what's going on here. It's actually just testing the circuit out to see um, what's going on in it, what it's doing electrically, I would say. And that's about it. So that's going to be the end of this video until my next test video. I'm gonna try to set up some more stuff, do more videos, share some test results, and um, I'll probably, I don't know if I want to put these databases up for people to download or anything if they have one of the UCore testers. But we'll get back to that. I'll think about that. Um, so they actually have a good database to actually test against if they want to test out their own stuff. But I can see where other companies or whatever want to take that information and forward it. I would say. But anyway, I'll end the video here. If you like this video, please like and subscribe, add some comments, let me know how I'm doing on this, and I'll see you next time. Thank you.